As part of the present administration's efforts to curtail the spread of coronavirus COVID-19 ravaging the country and the world at large, Edo State Ministry of Education, in collaboration with Edo Broadcasting Service (EBS) and Academic Staff Union of Secondary Schools (Asuss), is organizing a television program for students in senior secondary schools, particularly those writing the West African Senior School Certificate Examination (WASSCE), the National Examination Council (NECO), and National Business and Technical Examination Board (NABTEB) for the year 2020 in the months of May, June, and July. The program will be held on EBS television channel every day from 12 noon to 1 p.m. beginning from Monday, April 6, 2020. The subjects selected for these programs are Mondays Mathematics, Tuesdays English Language, Wednesdays Physics, Thursdays Biology, Fridays Geography, Saturdays Civic Education and Economics, and Sunday Chemistry. Parents and guardians are therefore advised to draw the attention of their children or wards to this opportunity during the stay-at-home period.
Viewers and students at home. My name is Mrs. Oshigwe M. Nana Fatima, a mathematics instructor. Today I'm going to take an aspect of statistics. Before I introduce the topic, let us do a recap of what we learned in our last class. In our last lesson, we learned about quadratic graph. In that quadratic graph, we constructed a table of values. Using the table of values, we constructed a quadratic graph. With the application of the graph, we were able to answer some related questions using the quadratic graph. Questions like the line of symmetry of the graph, the minimum value of y, because we had a U-shaped curve. Then we equally learned about the tangent or the gradient to the curve at a given point. Today we are going to take another important graph. This time is statistics. Statistics, we know that is a very important topic in mathematics. And we have been dealing with statistics right from primary school. And we'll be representing data in statistics. We have been representing data in statistics. Like in our primary school, we use picture to represent data. In junior secondary school, we use bar charts, pie charts, histogram, polygon frequency, polygon. These are all the various ways, graph that we use in statistics. But today we are going to talk about one particular one, which is called the cumulative frequency curve. Cumulative frequency curve. Cumulative frequency curve is a very interesting curve, a very interesting way of representing data in statistics. And to do that, we are going to look at a standard question. So this class, I refer to it as an examination-focused class, because we are going to be looking at a standard question, an examination question on cumulative frequency curve. And to do that, let us look at the question on the board. Can we read the question together? We have the frequency distribution table below shows the marks of 100 students in mathematics tests. You are given the marks. These are the marks. It's a grouped data. Then you have the number of students. Like you have here, from students that scored 1 to 10, they are just 2. 11 to 20, you have 4. 21 to 30, you have 9 of them. 31 to 40, you have 13 of them. Then 41 to 50, 18. 41 to 50, 18. 51 to 60, 31. Those that scored 61 to 70, you have 30 again. 71 to 80, 5. 80 to 93. Then 91 to 100, you have 1. So let us look at the questions that follows. The first question there says that we should construct a cumulative frequency table for the distribution. Construct a cumulative frequency table for the distribution. B says, draw the cumulative frequency curve for the distribution. C, use your curve to estimate Roman figure 1, median. Roman figure 2, interquartile range. Roman figure 3, the percentile. 4, what percentage of students scored at least 70 marks from your graph? If 80% of the students are to pass, what is the pass mark? I hope the questions are clear to us. So we are going to take the questions one after the other and what we are expected to do in an examination condition. The first question says we should construct a cumulative frequency table for the distribution. First of all, before we go, we are talking about cumulative frequency curve. Let us know, what is cumulative frequency curve? Cumulative frequency curve is sometimes referred to as a OGAN. Then what is cumulative frequency curve? It is a graph of cumulative frequency cumulative frequencies against the upper class boundary. Now to answer the first question, cumulative frequency table. We go back to the table that is given to us. Since we know that the curve is cumulative frequency against the upper class boundary, you bring out the table that is given to you. Let's go back to the table. I can copy it out again, or we just use what we have here. Since we are already aware that the curve is a curve, or the graph is a graph of cumulative frequency against the upper class boundary, we are going to create a column of cumulative frequency. You create a column of cumulative frequency. The question now is, what is cumulative frequency? How do we determine cumulative frequency? Cumulative frequency is just a running total of the frequencies. Is the running total or the successive addition of the frequency. That is what we refer to as a cumulative frequency. How do we do that? You take the first class. The frequency of the first class is 2. There is no class before that first class. So which means the cumulative frequency is going to be 2 for the first class. Then for the second class, the cumulative frequency will now give us these 2 you have here plus the next frequency 4, that will give us 6. Then go to the third class, you now have 6 plus 9 to give you 15. 15 plus 13, that will give you 28. Then you have 28 plus 18, and that will give you 46. Then 46 plus 32 to give 78. Then 78 plus 13 to give you 91. Then 91 plus 5, that will give you 96. Then your 96 plus 3 to give 99. Then 99 plus 1 to give 100. So this is how you determine the cumulative frequencies, the successive addition or a running total of the frequency. When you look at the question has earlier told you that the number of candidates that took this examination is 100. Your total here must be equal to 100. If it is not equal to 100, you check your addition again. It implies that your addition is wrong. Then now we've gotten our cumulative frequencies. The next thing we are going to look at is the class boundaries, because we have earlier defined cumulative frequency curve as a graph of the cumulative frequency against the upper class boundary. The question given, there is no upper class boundary, so you are going to create another column for upper class boundary. Then you create a column, put upper class boundary. Now another question. How do we determine upper class boundary? It is a very simple thing. Upper class boundary, when you look at the class given to you, in your class given to you, we are already aware that in any given class, the lower mark here is referred to as the lower limit, while this is the upper limit. Lower limit, upper limit. How do we get class boundary from this limit? To get the class boundary, the upper class boundary from this limit, in the lower limit, you subtract 0.5. In the upper limit, you add that 0.5. So which means the upper class boundary here will give you 10.5. I hope that is taken. 10.5. So you come to your table, you put the first class, the upper class boundary, you have 10.5. Then again, you add the 0.5 to 20. So the upper class boundary here will give you 20.5. Like that, you continue to fill the other upper class boundary. So here we are going to have 30.5, 40.5, 50.5, 60.5, 70.5, 80.5, 90.5, and 100.5. So you can see that this topic, the question is so easy. Once you know one, you can use that idea to complete the table. You don't need to crack your head or crack your brain. So this is what you do. This is our cumulative frequency, and this is our upper class boundary. Now, to draw, the second question says, draw the cumulative frequency curve for the distribution. So let's go to the graph. You use your graph sheets when answering this question, because you are going to use your graph to answer other questions. You must draw your graph to scale. You don't use a play sheet, because that is what most candidates do. You don't use play sheet when it comes to graph. So in this, you prepare your graph. This is your graph. Like we said, is a graph of cumulative frequency against the class boundary. You come to the graph, your vertical axis, that is where you put your cumulative frequency. Then your horizontal axis is where you have your upper class boundary. When you look at your cumulative frequency, the lowest mark there is 2, and the highest mark is 100. So you choose a convenient scale that this your graph can accommodate. For instance, I can decide to use 2 centimeters to represent 10 units. I can equally decide to use the same 2 centimeters to represent 20 units. But for the purpose of this class, so that we have a very large graph, let us use 2 centimeters to represent 10 units. In that case, I will label, I'm going to put my 10 here, assuming this is 2 centimeters. You can see, although it's not to scale, I'm not drawing to scale, like I advise that you come out with your graph book so that you can follow suit and draw to scale. Here you have 20, 30, 40, 50, 60, 70, 80, 90, then 100. That is for the cumulative frequency axis. Now let's go to the class boundary, the upper class boundary. The first upper class boundary. The first upper class boundary there, as you can see from the table, is 10.5. Then you put your 10.5 here. 10.5. The next one is 20.5, 30.5, 40.5, 50.5, to have 60.5, 70.5, 80.5, 90.5, then 100.5. Now, we have prepared our graph. So the next thing we do is to plot the points. We are now going to plot the points using the values given on the table there, using our cumulative frequency table. Look at this cumulative frequency table. When the cumulative frequency, when the class boundary is 10.5, the cumulative frequency is what? Is 2. How do you get your 2 from this? You remember we said 2 centimeters represents 10 units. In that 2 centimeters, you have 10 small boxes there. In 1 centimeter, you have 5 boxes. In 2 centimeters, you have 10 boxes, which means each box is equal to a unit. So that 2 units, you count 2 small boxes there, then you mark it like that. Then when the cumulative frequency is 20.5, sorry, when the class boundary is 20.5, the cumulative frequency is 6, which means we are going to count 6 of the small boxes along the 20.5 and mark it. When cumulative frequency is 30.5, when the class boundary is 30.5, cumulative frequency is 15. So 15 is between 10 and 20, then you mark it. When it is 40.5, the cumulative frequency is 28. I hope you can all see that. 28, close to 30. When it is 50.5, 50.5 will give us 46. 46, you trace it up until you get to your 46. right close to 50. When it is 60, the cumulative 60.5, the cumulative frequency is 78 there. I hope you can see that. 78, you trace it up. 70, 78 should be somewhere there. You mark it. When it is 70, 70.5, you have 91 there. 91, trace it up. This is 90, 91 should be somewhere there. When it is 80, 80 gives, 80.5 gives 96. 96, you trace it up, 96 is getting closer to 100. Then when it is 90.5, you have 99. 99 there. Then when it is 100.5, the cumulative frequency is 100. That is the last one to 100 there. Now, we have plotted the cumulative frequency points. So the next thing you do is to connect the points. We are going to connect the point now. This time you use your free hands to connect the point. You don't use your ruler. Because sometimes when we are marking, we discover that some students will just use ruler to join the point. And if you do that, you will not get a perfect curve. It will not give you the required curve. So you use your free hand to draw, to connect your points like this. So that is the required cumulative frequency curve. Now we have been able to answer question C. No, question B. Question B says we should draw the cumulative frequency curve for the distribution. Now we are through with the cumulative frequency curve. To the next question. This is the application where we are going to apply your cumulative frequency curve. That is the reason why I stressed earlier that you should draw your graph on your graph book so that you will be able to answer these subsequent questions. Because if you use your play sheet, you cannot estimate the median, the quarter, the interquartile range, or whatever the case may be, the question may ask you to do from a play sheet. There is no matter how accurate you are, you cannot use your play sheet to get the accurate answer. Now, let's answer these questions. The median. The first one says we should find the median from our graph. What is the median? The median, as the name implies, means the middle mark. Which of them is at the middle mark? And how do we determine the middle mark? To determine the middle mark, this is what you do. So to get the median is half of the total frequency. And what is the total frequency? The middle mark is at half of the total frequency. How do you get that? You have half. The total frequency, let's assume, is n. So if the total frequency, like we have here, the total frequency is 100. So you put your 100 here, your n is equal to 100. Then put your 100 there. That will give you 1 over 2 times 100 all over 1. 2 here will give you 1. 2 here will give you 50. That is the 50th mark. The 50th mark. So this 50th mark is only telling you the position where the median is. 50 is not the median, but the position that the median is occupying. I hope that is clear. So what do? You go to the column of cumulative frequency on your graph. Identify the 50th position. This is where you have the 50. Then you use your ruler, draw it to make the graph. Then you bring it down. So you will read the value here. So you go to your cumulative frequency axis, mark out the 50th mark, then you draw it to the graph, to the curve, then trace it down to your class boundary. The value, the mark here, is your median. That is how you determine your median. I hope that is clear. This is your median. Having done that, let's look at the second question. The second question says we should estimate the interquartile range. Before we go to interquartile range, what is quartiles? What do we mean by quartiles? Quartiles are referring to points that divide a distribution into 4 equal parts. That is what we mean by quartiles. And at this stage, the quartiles are just 3. Assuming we have quartiles. Quartiles are points that divide a distribution into 4 parts. In quartiles, we have 3 of them. There are 3. In that, assuming we have a line like this, this is the distribution. This is divided into 3. So this first line is known as the first quartile. This is the second quartile, and this is the third quartile. The first, second, and third quartile. Then, how do we determine the first quartile? Is referred to as the lower quartile. Sometimes we call it lower quartile, and is denoted by Q1. The second quartile, which is the same as the median, is denoted as a Q2. Then the third quartile, which we sometimes call the upper quartile, is denoted by Q3. Now, the question is asking us to find the interquartile range. Interquartile range. Interquartile range simply means the difference between the upper quartile and the lower quartile. That is Q3 minus Q1. Now the question, how do we determine Q1? And how do we determine Q3? Like I said in the case of a median, we are going to look for the position that the first quartile is occupying. How do we look for the position? The first quartile, which is Q1, because we are told that interquartile range is the difference between the first quartile and the upper quartile. So we have to look for the lower quartile. So to do that, you have 1/4 of the total frequency. The mark that is occupying that position is our first quartile. So, from our frequency distribution table, the total frequency is 100. So you have 1/4 times 100/1. So this will give us 4 here is 1, 4 here will give you 2 into 20, 25. So you have the 25th mark. The 25th mark from your frequency curve, cumulative frequency distribution curve will give you your first quartile. So how do you determine the marks from your graph? Again, you go back to your graph Identify your 25th position. 25th position is between 20 and 30. So you have your 25th position there. I hope my ruler is straight this time. So you have it. Then you draw it to the curve. To the curve. Once you meet the curve, bring it down to the axis where you have the marks. So this is your 25th position. Then you trace it down. The marks you have here is your first quarter. I hope that is taken. So your first quarter, Q1. That is your first quarter. Now, to determine the third quarter. To determine the third quarter, you still use the same method to find the position where the third quarter is. So your Q3, that is the third quarter, will give you 3 all over 4 times the total frequency, which is 100. So when you do that, 4 here will give you 1, 4 into 100 will give you 25. 25 times 3 will give you 75. That is the 75th mark. I'm emphasizing this because most time when you ask students to find the first quarter, the second quarter, they will be able to solve this very well. They will now give us this as the first quarter. This is the position that mark is occupying. It's not the mark itself. Please let us take note of that. What we are doing here is to determine the position where you have the mark. Then the mark, you are going to determine the mark from your graph. Then you go to your graph, the 75th mark. Along your cumulative frequency curve, go to where you have your 75th position. Should be around here. Again, you put your ruler there. Trace to the curve. Trace it to the curve. Then down to the axis where you have the marks. So whatever you have here is your Q3. That is your Q3. I hope that is taken. You must ensure that you trace it properly. So having done that, you've gotten your Q1, you've gotten your Q3. So the next thing is to go to the question properly. We go to the question properly. The question says you should find interquartile range. Interquartile range. So the interquartile range, as we have earlier stated, will give us Q3 minus Q1. So from my calculation, I'm going to give you the figure I have using my graph, because this one is not drawn to scale. Using my graph, I discovered that my Q1 is equal to, from the graph, Q1 is equal to 38.5. If you look at it, it's approximately like that, 28.5. Then my Q3, sorry, is 59.5 approximately. We may not get the same answer due to experimental error. So therefore, the interquartile range will give you 59.5 minus 38.5. When you do that, this will give you 0, 1, 2. So your interquartile range is 21.0, sorry. And sometimes you may be asked to find semi-interquartile range. Although it's not here now, in case you are asked to find semi-interquartile range, it's just the average of the interquartile range. What you do is to divide whatever you have here by 2. That is the semi-interquartile range. Let me just quickly add it. Semi-interquartile range, by way of formula, you have Q3 minus Q1 all over 2. So this will give us 59.5 minus 38.5 all over 2, which is equal to 21.0 all over 2, and that will give you what? 10.5. That is your semi-interquartile range. I hope that is clear to everyone at home. Now, let's go to the other questions. Now the third questions. Find the 60th percentile. Before we answer that, we have to ask ourselves, what is percentile? Percentiles are points that divide a given distribution into 100 equal parts, and they are just 99. Percentiles, they are points that divide a distribution into 100 equal parts, and there are 99 percentiles. Now we are asked to find the 60th percentile. Just the way we did that of quartile, the 60th percentile is just asking us the mark that occupies the 60th percentile. We are going to find the position, 60th percentile. First of all, look for the position of that mark. How do we find the position? That's 60 over 100 times the total number of distribution. How many are there? The total number of the distribution is 100. So you have 60 all over 100 times 100 all over 1. So that will give you the 60th mark. The 60th mark. That is what we mean by the 60th percentile. Then you go to the curve. The 60th position, that 60th position is just talking about the position that mark is occupying. I keep emphasizing this so that you will not make that mistake during your examination. The position is occupied. To get the mark, the 60th mark, you must read it from your curve. Then we'll now go to the curve. Go to your curve. This is where you have the 60th position. You draw it to the curve. Down to the horizontal axis where you have the marks. So the value, the marks you have here is your 60th percentile. The next question says, what percentage of students scored at least 70 marks? At least 70 marks. If we are told at least 70 marks, which means it can't be more than 70, but not less than 70. So what we do here, we first of all, at least 70 marks. That is 70 and above. It should not be less than 70. How many candidates or how many students scored marks as from 70 upward? How do you know that? So what you do, you go to the upper class boundary where you have the marks. This is where you have the marks, isn't it? Then you try to mark out 70 70 should be a little bit less than this 70.5 marks here. So you identify, since you are drawing to scale, you should be able to read 70 from there. But on the board, you cannot actually pinpoint where 70 is. With just an estimate. That is what I have here. So, which means from here up, they scored more than 70. 70 up. That is what that question is asking you. Then how do we now know the number of students that scored 70 and above? At least 70. That is 70 and above. You go to the Asuss, the upper class boundary where you have the marks. Identify your 70 marks there. Then you trace it up to the curve, then down to your cumulative frequency table, as is there. Then the marks here represent the number of students that scored 70 and above from here up. To get it, you are going to subtract whatever you have here. Assuming it's 95 you have here. I know it's more than that. If you draw to scale, it should be more than 95. Then assuming it's 95 you have here, then the number of students that scored at least 70 marks will give you 100 minus 95. So we are going to write that on the board. Number of students that scored at least 70 marks. From the graph, you are going to have it as 100 minus 95. So that will give you 5, which means 5 students scored at least 70 marks. Now to answer the question proper, because the question says we should find the percentage. We've only calculated the number of students. Now the percentage of students that scored at least 70 marks. You express this in percentage. So that will now give you the number of students that scored 70 marks all over the total number of students that wrote the exam, which is 100, then times 100 over 1. So that will go with that. We now have 5%. This is just an assumption. I'm not saying that the actual answer is 5%. But when you draw to scale using your graph, you will get the actual mark. I hope that is clear to everyone. So let us take the last but not the least question. The other question says, if 80% of the students are to pass, find the pass marks. This question sometimes is looking so technical. So if you approach it the way you are seeing it, okay, is it not 80%? Let me take 80% of the cumulative frequency. You go there, you draw it, blah, 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 and your answer comes out. You are going to fail it. You don't do it like that. The 80%, if 80% of the students pass, the 80% we are talking about is from the Asuss here. You have to take 80% from here down. Or another way you can approach it. If 80% of the students pass, it implies that 20% is going to fail. So that is how you approach this question. Yes, this is how you approach the question. If 80% of the students are to fail, then 20% are to pass, then 20% of them are to fail. So in that case, you take the 20th percentile. What this one means is, this implies 20th percentile. Then you take the 20th percentile we've already learned how to calculate percentile. You take 20 percentile, that will give you 20 all over 100 times 100 over 1. This is the 10. So that will give you 20, the 20th position. The mark that occupies the 20th position. So you now go back to your graph. Identify 20th position along the cumulative frequency axis. You trace to the curve. Alright, you go to your graph, you mark out the 20th percentile there, the position, then trace it down to the upper class boundary. The score you have here will give you the pass mark. If you draw your graph to scale, you will discover that the pass mark, according to what I have here, is 35 marks, 35%. So that is your pass mark. Like I said earlier, if you don't want to go through the problem of looking for the percentage that failed, you can start from the top. 80% of students are to pass. If 80% of students are to pass, start counting the percentage from up here. This is the beginning. We assume that this is the beginning. This will give us 10, 20, 30, 40, 50, 60, 70, 80. You can see that you are going to land at the same point if you use this same method. But if you start counting from up, you are now landing here 80. Are you not saying that the pass mark is going to be around close to 70? What happens to the others? So this is how you determine that. I hope the questions are clear and the solutions are equally clear too. So let us look at what we have done so far, and also to identify some of the mistakes some candidates do make when they are asked to draw cumulative frequency curve. Oftentimes we discover that when students are asked to draw cumulative frequency curve, instead of using the upper class boundary, they use the upper limits. They will just copy it from here. 10, 20, 30, 40, like that. If you do it, although you will get the curve, but your answers to these questions might not be correct. And as we mark, in marking the external examination, whatever step you take, there is a mark allocated to it. For being able to use your upper class boundary, you have your bonus mark. For creating that column, upper class boundary, you have your bonus mark. For using the upper class boundary correctly, you have your method mark. You can see if you decide to use the upper limit, you have missed 2 marks already. The accuracy, the bonus mark you will have for creating a table for the upper class boundary, you will miss it. For using it properly, you are going to miss it. Then again, your cumulative frequency. For being able to connect your point, plotting your point, you have marks allocated to it. That is why when you are answering questions from this section, which you cannot run away from, you must be careful to follow the question step by step. Because any step you take, there is a mark. Any step you take, no one is missing. There is a mark. We have the method mark, we have the bonus mark, we have the accuracy mark. So like this, when you plot a graph, you're able to plot it, you have a method That is the method. Then even though you are not able to read out, the method mark will be given to you, even when your accuracy mark is wrong. And if you have a wrong table too, like you have, because there is nobody that is above mid-state, it's possible that you are not able to get your class boundaries correctly. If your wrong class boundary that you have, and you are able to plot them, just the ones you have here, your method marks will be given to you, because you have used the values that you had to plot your graph. You cannot have a different value, a value here, then you are using a different value to plot your graph. So we have to be careful when plotting our graph. So like here, this is your 75th percentile, which is your upper quarter. So that is your cumulative frequency curve. I hope we have been able to learn something today from what we have done, and I'm sure by now you'll be looking forward to questions like this in your external examination. It's one of the questions that you cannot run away from, either in your NECO or your WAEC examination. So I will advise that you practice this one we have done. You go to your past question, look for a similar questions, and start answering them. So with this, I say thank you for listening.